Hi, today we are going to explain the shear stress in beam bending experiment. The objective of this experiment is to analyze the shear stress distribution in a E-beam subject to bending and to verify theoretical models such as effective braid correction proposed by Sketch. To achieve this, a hydraulic piston with a low cell was used to apply a controlled deflection at the center of the beam. A strain gauge were placed on the upper flange and a strain rosette was installed on the web and neutral axis. The strain were recorded using lab view, and the applied force was measured with a national instrument that Q system. The experiment allowed for a comparison between theoretical shear stress prediction and the measured strains and different locations along the beam cross section.
Oh, well, I'm gonna explain the start to how to you do the calculus. Uh, the first one, we are gonna obtain the different data, and I'm gonna reduce the data because the different program give me a lot of numbers. So that is the first step. We are gonna obtain the theoretical values. The theoretical values to first step, we are gonna obtain the inertial of the transversal beam. Then I'm gonna do different cut around the beam of transversal beams, and we're gonna obtain the shear stress distribution. Uh, then I'm gonna obtain the force, the maximum force, the shear force, and the Q total from the neutral axis. So then we're gonna obtain the tau and the shear force from the web, and then we are gonna obtain the lambda, that is tau over shear force. Then we are gonna graphic this graphic just for to see the result, and then we are gonna get the different normal strengths around the different strengths. Then I gonna obtain the normal stress max and the lambda over B. We know that the B is the measure of the transversal beam. Next,
Analysis of results. The shear stress distribution, a progressive increase in shear strain, was observed of the load applied by the hydraulic piston increase. This confirmed the beam is absorbed of the shear force and prediction the classical theoretical. The comparison with the theoretical model is shaded in the effective rate, the data, effective rate, the data is showed that the experimental effective rate different from the theoretical one, especially in the bending at the end of the experiment. The rate of the 13 and 14% some stage, like a dual 2, the system is instability and possible non-linear deformation in local buckling. And the circle of the Moore in this was constructed revealing a typical plane stress behavior, the circular radius with increasing load and the elliptical form, reflecting to the presence of the normal and shear stress. The orientation of the neutral axis varied of the load increase indication and the rotation toward to the stress domain. In conclusion, the experiment validated and the classical theory I was confirmed that the bin. All right, yes. The elastic behavior observed for the more tests, the aluminum being remain in the elastic range, allowing on the Hooke's law and more circle to the analysis. The importance of the instrument, proper calibration of the data acquisition system and the load call is essential to avoid accumulate errors, particularly when measuring small deformation. Thanks.